To measure something is a way to assess what you have, and measurements are definitely important. And if you're going to make a measurement, there's going to be a number and a unit associated with it. So the number is basically just to show the size or the magnitude of whatever you're looking at. And the unit is also important because it allows you to know what you're measuring. For example, in that value in the lower right-hand corner, you're measuring kilograms. You have 61.2 kilograms, which is mass. And that's a lot different than if you had 61.2 liters, which would be volume, or 61.2 seconds, which would be time. So both the number and the unit are very, very important. Now, one thing that drives chemists just something to think about, shall we say, when it comes to chemistry, is the uncertainty that's used. Because a lot of times you don't know for sure exactly how much you have. And we'll talk about that uncertainty and how that affects chemists in a little bit. Scientists will often use what's called an SI unit, which is basically a standard of units that scientists have agreed upon are kind of the ideal units. And they're really cool. The kilogram is the SI unit for mass, as well as the second for time and different things like that. Chemists often use SI units, but we always will sometimes use different kinds of units too. We'll see that as we go through the course. Here are the common types of units that are used. Length is usually in meters. That's the SI unit. Mass, as I said, is in kilograms, and time is in seconds. Temperature is usually recorded, officially anyway, in the Kelvin scale, which we'll talk about later. The other ones down there, amperes for current, which we'll use a little bit in Chem 223. Amount of substance is moles. We'll definitely talk about that. We don't talk about intensity of light very often, but if you do, it's the candela. So these are just things that scientists have agreed upon are pretty important. And it's not that you have to, for example, always use Kelvin temperatures for measuring temperature. We'll talk about how a lot of times when you're in the lab, chemists will use Celsius and convert to Kelvin. So Celsius is like the day-to-day version of temperature, but we'll convert to Kelvin when we're doing calculations, stuff like that. And there's lots of examples of this in chemistry and all the fields of science in general. It helps sometimes to figure out the magnitude, though, of what you've got. So, for example, if it comes to mass, the gram is kind of the base unit. But what if you have just like 1/10 of a gram, or maybe you have 1,000 grams, stuff like that. So the metric prefixes can be super helpful when it comes to mass. It also is really helpful when it comes to volume. It's helpful when it comes to time, all different kinds of things. And these metric prefixes are just terms that are used. So for example, if you had 1,000 grams, in scientific notation, 1,000 is 10 to the third. Well, 1,000 grams would be a kilogram. So you can see there the kilo, which has the symbol K, has a 10 to the third to it. And if you would then write right next to it a kilogram, that equals 10 to the third grams. So you can see there, like a kilogram is 10 to the third grams. But maybe you only have 1/1,000th of a gram. Well, 1/1,000th is 10 to the minus 3, which is above the kilo there. And you can see that 10 to the minus 3 is milli. So if you have a milligram, that equals 10 to the minus 3 grams. So metric prefixes can be really cool for representing large or small numbers depending on what you're using. And you can see there that there are 5 metric prefixes I really want you to know. I want you to memorize them because we're going to use them a lot. Nano, micro, milli, centa, kilo. Those 5 we're going to use quite a bit. And if we do use them, just you got to know what the prefix is. So milli, 10 to the minus 3, centa, 10 to the minus 2, etc. Now, micro there has a symbol M, and that is sometimes used. But another symbol that's used sometimes is what's called a mu. And it's a Greek letter. It looks like a U with a long kind of a tail in front of it. Mu is a lot of times used for micro as well. So just realize if you see that for micro, it's really important. I won't use little m for micro. I'll use little m for milli as I go through my stuff. But anyway, if you see them, just realize these are going to be important. And we'll see some examples of this here coming up. It's important to know the metric prefixes. Here's this poor person wishing for water, and this person sees a sign, water 9 kilometers or 50 meters. And they're like, oh, well, 9 is less than 50. I'll go for that. But, oh, man, a kilo is 1,000. So 9 kilometers would be 9 times 1,000, 9,000 meters. So it's farther to the water to the right than water to the left, which is only 50 meters. So it's very stupid and stuff, but you get the idea. Metrics might save your life one day. So we talked about mass, grams, kilograms, centigrams, all that kind of stuff. Another type of unit measurement that's really important in chemistry is length. And length is usually in terms of meters, which is the SI unit. So meters is important, but like before, you might have, say, 1,000 meters. And so knowing that 1,000 meters is a kilometer is important. On the other hand, if you had 1/1000th of a meter, that would be a millimeter. So these kind of units can be really, really helpful. And again, it just depends on how much kind of area you have. Now, in terms of length, in the good old United States of America, we are still really entrenched in the old, what's called empirical units, or the American units. And those are yards and feet and inches, stuff like that. And so a yard is a little less than a meter, and an inch is a little bit bigger than a centimeter, stuff like that. We will only use metric conversions in this class, at least to the level that I can support it anyway. That'll be really important. It's nice to know how to translate those. So there's 2.54 centimeters per inch, stuff like that you can translate. But in this class, metrics are really cool. Everything based on powers of 10 are just so much easier than the other ways of doing things. It's crazy. So on the left-hand side there, I have some useful conversions. The metric prefix for centa, for example, is 10 to the minus 2. So in terms of length, which is what we're talking about, 1 centimeter would be 10 to the minus 2 meters. But what people do a lot of times is they put the number over on the centimeter side. So if you wanted to convert 10 to the minus 2 meters equals 1 centimeter and put the number on the other side, you would divide both sides by 10 to the minus 2. And in a nutshell, what that means is you end up with 100 centimeters, 10 to the positive 2 if you're into that. 100 centimeters equals 1 meter, and those are really important conversions to know. Same thing down there for the millimeters. 10 millimeters equals a centimeter, or 1,000 millimeters equals 1 meter. You can convert back and forth. We're going to use a lot of light measurements here pretty soon, and that's where the nanometer comes in. Now, the official metric prefix for nano is 10 to the minus 9, so there's 10 to the minus 9 meters per 1 nanometer, but sometimes then we'll talk about how there's 10 to the 9th nanometers per 1 meter, and they're both fine. You can use either one you want, but just realize that there's a little bit of a difference depending on which scale you're using. Length, by the way, is defined as the distance light travels in a vacuum in that much of a second, and we'll see where that number comes from in a little bit, but it's a pretty cool kind of definition. That's where length is actually defined as. Mass actually is measured in terms of a platinum iridium alloy, which is kept in France. And that's where the idea of the kilogram comes from, which is kind of crazy. So that's where all of the symbols are. There's many different replicas, and they always worry about corrosion of the sample, blah, 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 but it's really helpful. Mass is, again, in terms of grams. So kilograms, milligrams, and grams are used a lot. 1,000 milligrams equals 1 gram. 1,000 grams equals a kilogram. So those are the ones that we'll use frequently as we go through this course and just kind of realize it. In biology, though, you might use, for example, a microgram, which is 10 to the minus 6 grams equals 1 microgram. So just realize there's going to be a few differences depending on where you are and what you're doing. But you can do all of this if you understand how this stuff works. Time is also important. Time is going to be more important to us in the next chapters, but time, as you know, is measured in seconds, minutes, hours, days, years, decades, etc., etc. Most of the time, chemists are pretty cool using just seconds to minutes and minutes to hours. So there's 60 seconds in a minute, 60 minutes in an hour, stuff like that, which is kind of cool. Time is really an interesting topic, and it's beyond what we need to talk about right now, but different fields of science will kind of describe time in different ways. And you can read that little picture in the lower right-hand side right there. That's, again, more than we need to talk about in Chemistry 221, But it is a fascinating topic to talk about. And maybe if you're taking this class in person, I'll talk to you more about what I think about it too.